Tabular method is awesome for a couple things. Products, like you're seeing right here. See this thing right here? That is ideal when you see, and it can't be done by use substitution, because sometimes you can just use substitute and get it out of the way. Look for that, but if that doesn't work, it might be integration by parts. The other is inverse trig functions and log functions in integrals. They tend to, they work wonderfully with integration by parts. You'll see many practice problems that reinforce that fact soon enough. But in the meantime, if I go to flip it, you just flip it. You just flip it. X squared or sine of x, which one gets to be u? Ready? Our fate is in your hands. No. I'm going to write u. It's going to be sine of x, right? Oh, you guys are killing. No. So, log, inverse trig, polynomial comes before a trig function as your choice of u. So you just work your way down, lip it. So x squared wins as the choice of u because of the acronym LIPIT. It's that powerful. It tells you all about you. If you ever want to know more about you, that's what college is all about, soul searching, finding out more about you. X squared sine x and a plus sign. That's the start of a table. U, dv, and the sign. So the tabular method is the same thing. You still pick your u, you still have a dv. The only thing we're adding to it is we put them in a table, x squared for our u, dv is sine of x. I didn't put the dx in there this time. Notice that, that's missing. And the first sign is going to be plus. Okay. I'm going to get to that table in just a minute, but first I'm going to go old-fashioned, and then I'll show you how the table matches what we're about to do the old-fashioned way. Okay, so here goes. Off to the side. This is the old way that we did it. It was great. It was fun. Got us closer as... Where's that? Choose something down. Yeah, that was the thing. You just did it? Oh, cool. I like this. This is good. Let's maybe we can have a moment too where I can get really mad. You choose it, and then I'll come over and get mad. That'd be cool. Yeah. Let's reenact the whole thing. Good idea. Alexia's got us all set up. She gets this. Boom. Are you guys okay with, now my integral of sine of x, derivative of cosine is negative sine. So I'm going to go negative cosine of x on this one. So this is old school. Same thing we just did a minute ago. So I'm just revamping the old integration by parts there. A little backwards Zorro. So I should get u times v, which is negative x squared cosine of x. Please ask if that scares you. Minus the integral of v du. You just switch it. I did, and it'll be plus 2x cosine of x. Fancy pants Frank over there is right. Got it. You okay with my uv minus the integral of v du, which was minus a negative, so I made it plus, on Frank's recommendation. So, can you integrate this? The question is this integrable? And it seems like it, but wait, can I do u substitution? If x is u, the derivative of that would just be, oh no. This is actually as non-integrable as the first one because I can't use u substitution and it's a product. Do you know what you have to do in that situation? Do it again. So we pick another, we do the same thing over again. We go u is the polynomial 2x. We're going to do parts again. Our dv is cosine of x dx. Oh my word. And then du is 2 dx. Ugh. And v is sine of x. Okay, well that's good. And we go to town. All right, so this is going to become a new uv minus v du. So 2x sine x. Buenos dias, Harrison. uv minus v du. So I'm going to put minus 2 integral sine x. We're just playing fun. We're just lipping it.
All right.
That's your turn. You just lip it. Okay. uv minus v du. I'm doing it again. Don't forget to bring down the stuff you already did. That's still there. X squared, negative x squared cosine x. Still there. I just had to do another integration by parts. Okay, now we're in a good place. I can integrate sine of x. And you can too. So we're basically there. Negative x squared cosine of x plus 2x sine x. And minus the integral of sine is cosine. But it's negative. Derivative of cosine is negative sine. So I think we get another sign change, right? Plus c. Holy macaroni. I like that one though. It looks cool. We just integrated by parts twice. I want you to see why we had to do it twice. I want you to see this. See if you can see what's on the horizon. Okay, I'm going to get a funny I'm going to get a really cool looking highlighter. How about orange? Orange is nice. No. Let's go with green again. So if you go back to the original, see that x squared? When I took the derivative of that 2x dx caused my next integral to have a 2x in it. X squared made me have a 2x. And that was the problem that caused me to have to do integration by parts again. Isn't that weird? So what if, so that caused me to take a second one and I got some answer, everything's good. What if this were x to the third? This is a huge what if. What if this were x to the third up here? That would mean this is like, what, 6x squared down in the, oh my. Wouldn't that happen? Right? That would be like 6x squared. Then we'd have to do parts 2 more times. We'd have to do 3 integration by parts if this were x cubed. So x squared caused us to have 2 integration by parts. Cubed, 3. X to the 4th, 4. X to the 5th, 5 times. And we literally, I think we just take the last bit of hope from Frank's outlook on life. What are you doing? Frank, you just collapsed. Come back. It's okay. Hang in there. Okay, so let's play on. That's the problem. If you put a polynomial up here, if U substitution doesn't work with that polynomial there, the degree of that polynomial actually tells you how many repetitive versions of this you're going to have to do if there's a trig function next to it. It's kind of a cool type of problem. Very common. So I think we need something that's quicker. And this is really quick, and you're going to love this part. This is called the tabular method. It's for this repeated integration by parts process. There's a pattern to it. So here's how you set up the tabular method. We're just going to end up taking derivatives of the u's all the way down, and we're going to end up taking integrals of all the dv's all the way down, and we actually, so the process just repeats itself over and over again. Watch this. You can actually do that all ahead of time. So I'm going to take a derivative of x squared and get 2x. Take a derivative again and get 2. Take the derivative again and get 0. With a polynomial as your u, you stop when you can't take the derivative anymore. You just keep going. And then sine of x, integral of sine of x, negative cosine of x. The integral of negative cosine is negative sine. And then finally, the integral of negative sine is cosine. Now, the sign thing, the plus sign that I started with, it always starts plus, and then it alternates. If you think about integration by parts, that minus v du, if it's embedded inside another integration by parts, the minus v du in each layer is going to cancel. It's going to alternate the sign back and forth is what's going to happen. So the layers change sign, and that's why you have that plus minus plus minus plus minus. Here's where integration by parts gets interesting. All you do is set this up by taking derivatives down the left, till you can't anymore, at least for now. Integrals down the middle. Start with a plus sign and alternate as long as you need to. This could go as long as you want it. Doesn't matter. Diagonal product, tack on this sign. Diagonal product, tack on this sign. Diagonal product. Done. Are you ready to see this? The first diagonal product, I'm going to back up and show it to you one more time because it's really fun. X squared times negative cosine of squared of x. That's my first part of the quotient of integration by parts. X squared times negative cosine of x. Then I'm going to change colors on you, so watch out. Going purple. 2x times negative sine of x. You see that right there, but you notice it has a different sign. Right after our x squared times negative cosine squared of x, you tack on that sign that's right after it. So what happens, what we're not seeing down here, is it's actually minus a negative right there. Okay, so there's, the product is negative. You have minus a negative. Then you tack the sign on that's right after it, so I'm going to change colors on you. So this right here, you put a plus sign after it. Okay. So if you look down below, we got our first diagonal product in green. Ooh yeah, right here. Then I put in that negative sign, and then it had the next diagonal product in purple, and it had its own negative sign, so it ended up being plus. Yeah, right there, purple. Then we put this plus sign that I just came up with. See that plus sign that I just got in there? See, it's right here to match this one right here. Then the next diagonal product was, let's choose yellow on this one. 2 cosine of x, 2 cosine of x. And then when you're at the end of your table, you're done, and you just put a plus c at the end. Is that not cool? So I'm going to walk over to that wall. It's a quick process. Diagonal product, tack on the sign. Diagonal product, tack on the sign. Diagonal product, and when you're at the end of your table, plus c and you're done. So same result. So it's not magic, it's just picking up on the pattern that this table is, if you can think about it, what these things are. In the way the table is set up, I gotta pick the perfect coloring. Let's go light blue. This is our u, and this is our v. So that diagonal is always the u times v. That blue times blue is u times v. And then here's your minus your next product of those as it keeps going down. That's u dot v, u dot v. And then the final thing you end with, well, I'll kind of close it out and show you how it all works in the end, but it's very slick. So we should use it a couple times, and then you'll get a whole lot more out of it because it's really kind of fun. Okay, so we just did that for that problem. Let's skip the page. 9 is the same problem. It's just saying to do it using that method. Look at that t to the 4th. That's 4 integrations in a row if we're thinking back to what I saw last time. That would be awful. Okay, so
our next page isn't.
we're going home. Yes. We are done. Or I could just give you the next page. All right. You were close. You were so ready to go. There on. Back. Totally tabular. So Lipit still is in place. So we go up here and say, all right, Lipit, what's my u? So you go Lipit. And you go, all right, I'm looking for a log. Nope. Inverse trig. Nope. Polynomial. Got it. That's your first u. You choose that as your u. So the table sets up u, d, v, and the sign thing. That's how you start it. Crisscross. And u was t to the 4th. Then that means dv is everything else, e to the 2t. We don't have to put the dt part on there. And then you derive the t to the 4th so you can't anymore. So t to the 4th becomes 4t cubed. It becomes 12t squared, 24t, 24,